Hello, dear students. So this is our another lecture on these complex analysis, and today's topic is about branch points and branch cuts. And in our previous lecture, I have discussed it about I give you a little bit idea about what's basically branch point and branch cut, how these are Riemann surface helps us to tackle such kind of problems. Because if you take some logarithmic function of some modulus of square root of z or z raised power 1 by 3, so that means we can do mapping from this z plane to that this w plane, or we can say that which is basically square root of z raised power 1 by 2, right? And we basically see that we have these branch points as well as branch cutters. So branch points basically connect to the two regions. So we have discussed that in our previous lecture. And similarly, branch cuts will be where there will be discontinuities in between the two regions, right? If you have these two rival surfaces, so we are basically saying that this is z equal to 0 and this first sheet. And this was second that Riemann sheet, right? And z equal to 0 is basically that point which is called the branch point, and it connects to the two regions or two Riemann sheets, right? And similarly, we can have another branch point which exists at z equal to infinity, right? So similarly, if we talk about some in previous topic, we have also talked about that if I have some natural log of z, and we see that it basically have multi-valued functions. So if we like we have this, if you remember that we have done that f of z equal to, that is, if you take that ln of z, right, or this, which is equal to that ln of r plus iota into theta plus and this is equal to ln of r plus iota. And this theta, this capital theta is basically the argument, and if you take for different values of these n, so you are getting that different value. So that this line natural log of z has this many values, which is basically called a multi-values, right? Now, if we precise, so if we choose that angle, so if we cut those points, right? So if we choose that theta plus 2 pi is some 2 pi, right? So we're basically making from multi-value to single value function, right? So that's basically that cut, where basically if we confine that angle theta plus 2 pi equal to some 2 pi, then we this function it can have a single value, right? So that point where basically we make that multi-valued function to a single value, that's basically called the branch cut, right? And that branch cut is basically so you can have branch cut between this portion. So these are basically where the discontinuity exists between the two infinite these plane sheets or Riemann surfaces. And these are our branch cuts, and this is basically the branch point which connects the two regions. And in addition to that, also मैंने आपको और एक चीज बताया था, because the value this sheet that it has in that in sheet first, it should have same value as what you have value at this point in the second Riemann sheet, right? Because z equal to 0, it connects these two sheets, these two Riemann surfaces, and the value at in the first sheet at this point should be equal to this point by the condition of continuity, right? And so we can take so many examples. If we have that f of z equal to some, we can have this f of z equal to, if we have that ln of z minus 1. So that means, so z equal to 1 is basically the branch point for this, right? Because we are shifting, if you are moving 1 unit away from this origin, because z equal to 0, if you move 1 unit away from it, towards left or right, towards right, right? So this, that's basically the branch point for this, or that we can say that singularity exists for this function, right? Now, I will give one example and we'll see so the different the branch points as well as the branch cuts for that function. If we take some function, suppose if we have this f of z equal to, right? So we have, this is our function, and this p and q, these are basically so you can, I cannot draw this infinite that Riemann surfaces, because we can have four Riemann surfaces here, because for this, because we have that z raised power 1 by 2, so we need two Riemann surfaces here, and similarly for this function we need two more Riemann surfaces. So these are basically interlinked with each other, so I cannot draw that. I simply draw that complex plane. We can have here two functions, right? So this is x and y, and here this 0 is less than p, less than, right? So that means these p and q are positive integers, and let us draw these points in our complex plane first, right? So that means we can have, so we have 2 points here. If we consider 2 points p and q, right? So that means we can have infinite number of branch points as well as branch cutters over this line. If we extend it from this to infinity, and similarly this can have the branch cuts as well as the branch points over this real axis, right? Now, instead of that, so first let us check the phases at the different regions, right? So first we write for this function, we have two functions here, so that means we have two Riemann surfaces for first function, and similarly two Riemann surfaces for second function, right? So I can first write that. So for this function, so let's write for this. We can write for z minus p raised power 1 by 2. Let's start for this function. So that means I can draw it like this, and this is our function, that is z minus p raised power 1 by 2. Okay, and so this is our p here. Okay, and that means our p is some positive integer, so you can have some 2 or 3 units away from that point. So this is basically why this z minus p raised power 1 by 2 lies. Okay, because this is very clear. So that means first, if you choose that, let's write down the phases. Let's write down the phases in the all the regions, like because we have many regions for this function. Because we can take towards the right of that point P and towards its left, or you can go down to this point in the second, the fourth quadrant, and similarly you can check for the third quadrant. So that means we need to write down all the phases, right? So first for this function and similarly for the second, right? So for first function, so let me write it here. So better is to write here. So we can have this. This is our x, y. Okay. So let's write down the phases. Right. So first let us write down for this portion, for this region, for region first. So इस वाले region में हम देखेंगे. So that means when you define the write down the function for this one, so that will be that modulus of that function into e raised power iota that phase, right? So that means that is the value of the function in this region, right? So first, if you write for this, because if you choose now, because p is our some positive integer, like if you choose that p equal to, so for first, so that means this वाला इस region में हमें देखना है, right? तो अगर हम for example अगर हम p में यहाँ पे लूँगा, it will be some 6 and z equal to some 7, right? So then our z minus p raised power 1 by 2, it will be 1 raised power 1 by 2, right? So because if you take that, so here the phase will be, because it is close to a real axis, so the phase will be 0 here, right? So that means the phase in this portion for this p equal to 1, so phase above the real axis, phase will be 0. Okay, so that means यहाँ पे जो हमारा phase होगा, that will be 0 here. Now second region is this one, right? So that means यहाँ पे जो phase होगा, or you can say the argument here, because theta will be 0 here above the real axis. Okay. Now here in region second, because it is going from 0 to pi, because हमें ये वाला portion देखना है. We need to check this portion. So यहाँ पे क्या होगा? So in this portion, so it is going from 0 to pi, right? So that means what will be the argument for this? Because this will run from, because when it goes from 0 to pi, because it has z minus p raised power 1 by 2, so that will be e raised power iota theta by 2, right? So when it goes from 0 to pi, तो जो यहाँ पे फेज होगा it will be pi by 2, because it has raised power 1 by 2. तो इसका जो आर्गुमेंट है, so that will go from this it is going from 0 to pi in z plane. So but for this it will, because it's raised power 1 by 2, it will be iota pi by 2. So that means जो phase यहाँ पे चेंज होगा, so for this one, so that will be pi by 2. Okay. So this is second part. Okay. And similarly, if you check now, so for second, so the phase will change from pi by 2, because जो हमारा function यहाँ पे है, it is going from, z is going from 0 to pi, but z minus p raised power 1 by 2, it will be pi by 2, because we have raised power 1 by 2. So इसका argument जो होगा, it will change by pi by 2. And similarly, if you check the third region, so that means ये वाला region, okay. So if you check for this region, for region third, so our region third is, so region third is this one. तो यहाँ पे क्या होगा, because now it will go from pi to 2 pi, right? So when it goes from, so that means it is changing, that this function will go from, it's changing now 2 pi, but we have raised power 1 by 2, so that means z minus p raised power 1 by 2 will change to that is 2 pi by divided by 2, right? So that means here for third, so this is for second, so for second, so phase will be, that will be pi by 2, as z minus p, it will change to pi, so z minus p raised power 1 by 2 will be pi by 2, right? And similarly for third region, so for third case, so that means for third one, because it will go from pi to 2 pi, so it is changing 2 pi now. So 2 pi means, because when it changes to 2 pi, so this will be z minus p raised power 1 by 2 will be 2 pi divided by 2, so it will be pi. So in the third case, our phase will be, that will be pi, right? So यहाँ पे जो हमारा phase होगा, that will be equal to pi, right? So these are basically all the three regions. First towards it is towards the right of this point Q. Sorry, it is P. Sorry. So this was point P. Okay. So towards the right, above the real axis, the phase is 0, and towards its left it is pi by 2, and below that real axis we can have pi, right? तो अगर हम ऐसे ही check करेंगे, if we are going to check for this another function, that is basically that z minus q raised power 1 by 2, we can have same kind of trend, because we have that if z minus q, so for first region, तो मैं लिख सकता हूँ, जैसे मैंने इसके लिए लिखा था, फर्स्ट रीजन के लिए 0 होगा, and then second region it will be pi by 2, and in this third region it will be pi, because our function is that f of z is equal to z minus, that is z minus p raised power 1 by 2. So instead of p we have now q is also a positive integer, it has some units away from that point, right? So we can write then for this z minus q, so we can have point q is here, right? So phase will be 0 here, and again for this region it will be pi by 2. So this is basically for z minus q raised power 1 by 2. And for this case, so this is our region first, this is second, and in third we have pi. Okay. So these are all the possible cases for if we write for z minus q raised power 1 by 2. So we have both the phases for the first function, that is z minus p raised power 1 by 2, and also for z minus q raised power 1 by 2. So let us combine them. So that means for this function, if we write now, so if you write down for now, But there's a problem, sorry. So there's a problem because, so for this will be 0. Now for this it will be pi up to this point, right? And for this one, so if you write for this q below that, right? So for this region it will be that pi. Okay. So for this region, because we have, okay, so these are basically phases for this. Okay, that's correct. That's correct. Right. That's correct. Now let us write down the phases for the force function. So now we write for, we will write down for phases of that z minus p raised power 1 by 2, z minus q raised power 1 by, right? So these are functions, so we need to write down the phases for this, right? So because we have the product of the two functions, and हमने लिखा था we write down that the phases for different for individual functions for first z minus p raised power 1 by 2 and z minus q raised. Because now when you add the, so you need to, because we have the product of these functions, but you need to add the phases. If you have the phases for first and second, you need to add up them, right? So that means the total phase will be the addition of these two, right? So because we have, so अगर हम देखेंगे, because we have now our function is this one. So this is our x, y. So this is our p, and this is our q, right? तो अगर हम यहाँ पे देखेंगे, so first अगर हम ये वाला रीजन देखेंगे, okay, let's check. तो अगर हम इस वाले पॉइंट पे देखेंगे फर्स्ट फेज इन फर्स्ट रीजन, तो अगर हम देखेंगे यहाँ पे जो फर्स्ट रीजन है, यहाँ पे टुवर्ड्स द लेफ्ट, टुवर्ड्स द राइट ऑफ दैट पॉइंट क्यू, यहाँ पे फेज 0 है. तो सिमिलरली अगर हम यहाँ पे देखेंगे टुवर्ड्स द राइट ऑफ पॉइंट पी, फेज इज 0, सो दैट मीन 0 प्लस 0, राइट? सो दैट मीन जो फेज होगा यहाँ पे इस वाले रीजन में, तो फर्स्ट में क्या होगा फेज, सो दैट विल बी 0, right? And now second रीजन, तो सेकंड वाले रीजन में क्या होगा? तो सेकंड वाले रीजन में पहले हम देखेंगे, if we want to check for this point P, मगर क्यों जो पॉइंट है it basically changes. अगर हम इसके towards left देखेंगे, towards the left it will change by pi by 2. The function that z minus q raised power 1 by 2, it changed its phase by pi by 2. तो इसके लिए क्यों के लिए क्या होगा? तो क्यों के लिए ये फेज चेंज करेगा कितना? तो because we have, इसके लिए pi by 2 चेंज करना है, so that means, so that will be pi by 2 from here, from q plus जो फेज p पॉइंट, तो अगर हम p पॉइंट देखेंगे, लेट अस चेक इट हियर, तो जो p पॉइंट है ये इसके राइट में आ रहा है, राइट? तो पॉइंट p के राइट साइड में, बिकॉज देयर इज नो फेज चेंज, फेज इज 0, so that means यहाँ पे जो पॉइंट p के लिए है, क्योंकि इसके टुवर्ड्स राइट साइड वो फेज 0 आ रहा है, so it will be 0. So total phase change will be pi by, right? So this is for second region. तो सेकंड के लिए क्या आएगा? तो यहाँ पे आएगा 0, तो here it will be pi by 2. तो अगर हम थर्ड रीजन देखेंगे, ये वाला रीजन, तो इन थर्ड रीजन इफ यू चेक, तो थर्ड वाले रीजन में क्या होगा? तो अगर हम चेक करेंगे फॉर पॉइंट क्यू फर्स्ट, तो क्यू के लेफ्ट में आ रहा है, इट इज चेंजिंग द फेज बाय पाई बाय 2. एंड सिमिलरली फॉर पॉइंट पी, तो ये जो पॉइंट यहाँ पे आ रहा है, तो टुवर्ड्स द लेफ्ट, बिकॉज यहाँ पे जो रीजन आ रहा है, इट इज टुवर्ड्स द लेफ्ट ऑफ दिस पी, तो अगेन इट इज चेंजिंग पाई बाय 2. तो ये भी पाई बाय 2 चेंज हो रहा है, ये भी पाई बाय 2 चेंज हो रहा है. सो दैट मीन्स जो थर्ड वाला रीजन हमारा है, तो जो थर्ड रीजन है, तो इट विल बी पाई बाय 2 प्लस पाई बाय, so that means that will be equal to pi. So that means in this region the phase will change by pi, total phase will be pi. And similarly if you go down, right, so in fifth region, so that means if you go in this region, fourth region, तो फोर्थ रीजन में क्या होगा? तो दैट मीन्स हम कहां पे देख रहे हैं? अगर हम यहां पे देखेंगे क्यों के लिए, बिकॉज क्यू के इस साइड में टूवर्ड्स द राइट बट डाउन, तो यहाँ पे इट चेंजेस द फेज बाय पाई। तो दैट मीन्स यहाँ पे क्या हो रहा है, दिस पॉइंट क्यू, सॉरी बिकॉज दिस इज आवर पॉइंट क्यू, तो इसके ये जो रीजन आ रहा है इट इज टुवर्ड्स द लेफ्ट ऑफ दिस रीजन। तो अगर हम टुवर्ड्स द लेफ्ट ऑफ दिस रीजन, यहाँ पे टोटल फेज आ रहा है पाई बाई टू, राइट। तो दैट मीन्स यहाँ से ड्यू टू क्यू वी कैन राइट देन, तो यहाँ से इसकी वजह से आ रहा है दैट विल बी पाई बाई टू हियर, बिकॉज इट इज कमिंग टुवर्ड्स इट इज लेफ्ट साइड, तो यहाँ से पाई बाई टू आ रहा है। बट पॉइंट पी के लिए अगर हम पॉइंट पी देखेंगे, ये पॉइंट पी के इस साइड में आ रहा है, तो पॉइंट पी अगर हम देखेंगे, अगर टुवर्ड्स द राइट साइड हम देखेंगे, ये कितना चेंज कर रहा है, पाई। सो दैट मीन्स पॉइंट पी जो हमारा है ये चेंज कर रहा है फेज बाय पाई, बट पॉइंट क्यू it change its phase by pi by 2, it will be pi plus pi by 2, it will be 3 pi by 2. So that means we can have this fourth region, so that will be pi plus pi by 2, so that will be 3 pi by, right. And similarly the last region, that's fifth region, so this region, तो इस रीजन के लिए क्या आएगा, तो इस रीजन के लिए क्या आएगा, तो जो क्यू है ये क्यू के राइट साइड में आ रहा है, तो क्यू के राइट साइड में चेंजेस पाई बाई दिस फेज बाई पाई, तो यहाँ पे पाई आ रहा है, तो पी के भी राइट साइड में आ रहा है, इट विल बी अगेन पाई, सो इट विल बी पाई प्लस पाई, बिकॉज दोनों ये टुवर्ड द राइट आ रहा है। तो अगर हम फंक्शन देखेंगे दैट z माइनस पी रेज पावर 1 बाई 2 और z माइनस क्यू रेज पावर 1 बाई 2 बोथ चेंज फेज बाई पाई, अगर पॉइंट है, अगर हम टुवर्ड्स द राइट साइड ऑफ दैट पॉइंट देखेंगे, बिकॉज ये जो रीजन आ रहा है ये इन दो पॉइंट के राइट साइड में आ रहा है, तो बोथ चेंजेस फेज बाय पाई, so that is pi plus pi, that will be 2 pi. So that is what I need to write here for fifth region, जो phase यहाँ पे आएगा that will be pi plus pi, so that will be 2 pi, right. So that means we can have all the four regions, that is P here, this is Q, this is region first, fourth, right. So we have all the four regions, and now अगर हमें if we want to write down the function, so if you write down the function at this in this region, so it will be the modulus of that function into e raised power iota into phase, because यहाँ पे phase क्या है, e raised power that's iota into 0, right, so that's 1. So that means अगर हम if we write the modulus value of that, right, so that means we can write then now the actual value, now the actual function is, so actual function क्या होगी, so that will be, that's the modulus of, so because x stands for the modulus of that function, right, and that x equal to, that's equal to z minus p raised power 1 by 2, z minus q raised power 1 by, right. तो अगर हम इस वाले रीजन में देखेंगे, तो बिकॉज सो इन दिस रीजन, तो इस वाले रीजन में अगर हम फर्स्ट रीजन में देखेंगे, तो फर्स्ट रीजन में क्या आएगा, तो रीजन फर्स्ट में आएगा दैट विल बी इक्वल टू that will be modulus of that e power iota into phase is 0, so that is equal to x modulus of that function, तो यहाँ पे हमारा आएगा x सिंपली। एंड सिमिलरली अगर हम सेकंड रीजन में देखेंगे, तो जो सेकंड रीजन होगा, सो लेट मी राइट इट हियर, सो फर्स्ट रीजन में क्या आएगा, so that will be equal to e power iota into 0 into that modulus of that function, that will be x, so x stands for the modulus of that function, right. And similarly region second, तो region second में क्या होगा, so that will be equal to e raised power, that is हम देखेंगे यहाँ पे कितना है, so phase कितना है सेकंड में, that is pi by 2, so pi by 2 is that is iota pi by 2 into chi, so that's iota pi by 2 is that's equal to 1, so this will be simply equal to, so that will be equal to iota into, so that means यहाँ पे क्या आएगा iota into, right. And similarly third region, तो थर्ड रीजन में क्या आएगा, e raised power iota 3 pi by 2, iota pi sorry, that will be e raised power iota by, that's minus iota, तो यहाँ पे आएगा minus iota into, so minus iota का up to this point, right? And in fourth region, so that is fourth, तो fourth में क्या आएगा, it is e raised power iota 3 pi by 2 into chi, so that will be equal to, तो वो क्या आएगा fourth region में, that will be e raised power iota 3 pi by 2 into chi, so that will be equal to minus iota chi, right? And in the fifth case, तो fifth में क्या आएगा, in fifth it will be chi into e raised power iota 2 pi, so that will be there is no change in chi, so that means जो function यहाँ पे आ रहे हैं, we can have, तो जो हमारी function है in all the three regions, that is this point P, this is point Q, right, and this is first region, second, third, fourth, fifth. So here it is chi, here it is chi, here it is iota chi, this is minus iota chi, and this is, and what is there then, minus iota chi, right? So that means if we extend it up to infinity, so that means this will this will vanish, because we can, this will cancel out with this thing, right? So that means we cannot have branch cuts at z equal to infinity here, because this will cancel with this thing, right? And we can have finite branch cut here, because, so branch cut will be here because we have this iota chi into minus iota chi, so that means, so this will be that finite cut here. Why? Because अगर हम इसको extend करेंगे तो ये these will cancel out, because if you take that z equal to infinity, we can have this value of this function at this equal to chi, and we can have again this, that's the modulus of that function. And but at these points, because we have these branch cuts will be here, right? Because we have just iota chi and minus iota chi, so that means there will be no branch cuts for this function, so there will be no branch cut. तो वहां पे कोई ब्रांच कट नहीं होगा एट z इक्वल टू, राइट, बिकॉज इट विल कैंसिल आउट, तो ये कैंसिल आउट हो जाएगा, राइट? एंड दिस इज बेसिकली हाउ वी कैन डिफाइन द ब्रांच कट्स, एंड so we can also check what kind of branch cuts it can have. It can have some, at z equal to infinity it can have some branch cuts for some functions, right? But for this function we can have by finite branch cut, and it exists between point P and point Q. So I think hopefully we will discuss some more problems on this topic in our next video. Thank you.